lecture is on bioreactor monitoring and control. This part of the fermentation laboratory class is going to be a little bit more theoretical, and I think it's important for you to know the theory behind the fermentation processes. I will try to keep it as brief as I think you really will find interesting, but I also think that you need to know what's going on behind the process as much as possible, even though it's actually a very complex process, and so it would be unreasonable for you to know everything. I think it would be impossible for you to know everything about fermentation from taking this class. But nevertheless, it's not enough just to know how to go in there and plug it in and turn it on and analyze some data. You want to know more about that, a little bit more than just, how to be an operator, because you are a chemical engineer and you are going to be hired as an engineer, not as an operator. So, with that thought in mind, let us go a little deeper into fermentation. So, for the purpose of this lecture is to talk about the different aspects of controlling the fermenter. And there are different variables in the process that we need to think about because they can influence how the process goes. For example, the dissolved oxygen is important for aerobic bacteria. The pH is important for all bacteria, and I'm going to explain a little bit more deeply why it's so important to control pH carefully. The temperature is also very important, and we will be able to monitor the components of the off gas so that you can monitor what's actually happening metabolically in the process. And finally, we will also monitor the concentration of substrate in the reactor, and we will also keep track of how much total substrate is fed. These are some useful references for your further study in fermentation. This is a high-level process control book, but if you are interested in fermentation control, this is an excellent book. This one is also more detailed in terms of the biochemistry of the processes, and it has a lot about different kinds of bacteria and organisms that you may be using in the future. This one you should have had if you took Chem 192 last semester, and it also talks about fermentation and about control. And this is a very high-level book about bioprocess control that is really about model-based control of bioprocesses. So, first of all, let's talk a little bit about process control. You're going to take that class this spring semester, and so you're going to learn this in more detail, but just to introduce you to the concepts, if you haven't already seen them, this is going to be a general picture of a fermentation process, although this term chemostat is specific to fermentation processes. It basically is a bio term for CSTR, which you have learned in your kinetics class. What it basically means is that we're going to reach a steady state in this process. We will not be running a chemostat in our class. The only difference between this process and the one that we will run is that we will not have any outlet for the broth to be removed. So our process is an inherently unsteady state process. It's called a fed batch, and I will give you more details about that a little bit later on. We will be feeding air to give oxygen to the bacteria. We will be feeding in nutrient because the initial charge of substrate will not be sufficient for the bacteria to grow. And we will be removing off gas that is produced during the fermentation. We need to remove that because if not, we would have an explosion. And we will also monitor the components of that off gas. So let's talk a little bit about controlling this process. As a steady state process, what are some things that we want to be able to control? Well, one of them would be the liquid level. We would want to keep the level of the liquid constant if it were a chemostat. To do that, we could use a level probe. This is an electronic probe that senses the presence of liquid at the end of it. And we can use that to shut off the feed pump when the level has reached the level that we want to maintain it at. The other thing we want to look at in this particular story that we're talking in this particular slide is to control the concentration of oxygen in the fermenter. To do that, we will use a dissolved oxygen probe. This is a electronic probe that has a small chemical reaction and is able to actually chemically measure the oxygen. Oxygen will diffuse through the end of the probe, so we have a mass transfer calculation that we could do to figure out what's the time constant of our probe. And this is going to monitor the concentration of oxygen that has been dissolved in the liquid. So this is a very important parameter for our process if it is an aerobic bacteria. So, let's see, sorry. Okay, so when we're talking about process control, some of the definitions of variables that we would pay attention to are input variables. These are the variables that can independently stimulate the system and thereby induce change in the internal conditions of the process. And that's one kind of process that it's a process input. And the things that we cannot control, but that we use to obtain information about our system, would be an output variable. An example of an output variable in our system would be the off-gas CO2 concentration. That would be an output variable. We can tell what's going on in our bacteria by determining what is the concentration of CO2 in the off-gas. That would be an example of an output variable. An input variable would be the concentration of glucose in the system. Okay, next. Let's see, I'm trying to go forward. Okay, so there's two types of input variables. Those we can manipulate or control, and those that we cannot control. These are called disturbance variables. So, for example, we can control the heat. We control the heat input into our process, but there's also going to be metabolic heat generated in our process. So this would be an example of a disturbance variable that we have to react to an increase in metabolic heat by cooling the system. Okay, we can separately identify variables that we can measure. All right, so oops, I'm still having a problem going forward. Okay, here we go. So this one I'm sure you've seen in your classes, but this is the concept of feedback control. Okay, I mean, a feedback control in our daily life is using the cruise control in our car. You choose a set point. Speed limit is 65. You choose, say, 70. And you want the car to go 70 miles an hour, but you don't want to have to keep pushing your foot on the gas. So this is going to be the set point. The disturbance would be